Welcome to the news. Today we're going to talk about chemistry in our lives. We're going with you, Luis. You're going to talk about chemistry and medicine.
Thank you, Ricardo. Now, in other news, many doctors have agreed that a big step for actual medicine will be to start applying nanomedicine, that is based in molecular nanotechnology, and it has been defined as the three-dimensional positional control of molecular structure to create materials and devices to molecular precision. The human body is comprised of molecules, hence the availability of molecular nanotechnology will permit dramatic progress in human medical services, more than just an extension of molecular medicine. Nanomedicine will employ molecular machine systems to address medical problems, and will use molecular knowledge to maintain and improve human health at the molecular scale. Nanomedicine will have extraordinary and far-reaching implications for the medical profession, for the definition of disease, for the diagnosis and treatment of medical conditions including aging, and ultimately for the improvement and extension of natural human biological structure and function. In some simple words, nanomedicine is the preservation and improvement of human health using molecular tools and molecular knowledge of the human body. And the other article that I have to you is about the food and the chemistry, how they are related. And it says that food scientists think of cooking in terms of the combination of food, chemicals, and the reactions they undergo to form a new food product. Our food is made up of chemicals. Proteins, carbohydrates, and fats are particular types of molecules and amino acids that combine in predictable ways to make up a food. Taste, texture, and appearance can be altered by the addition or substitution of chemical food components. Food scientists work with food chemistry to develop new ways to use and combine ingredients. They study the chemistry of the food to determine the properties of each food component and how it functions in the final food product. Working with natural and artificial ingredients, they develop stabilizers, flavorings, and new ways to combine a present food. Food scientists spend a lot of time on research. They study the medical properties of the food components, how they combine and deteriorate, how to improve their nutrition, flavor, and storage qualities. The research encompasses a number of science disciplines, but most of the work involves chemistry. Now I'll let you with the next section of this program.
Now we're going with you, Diego. You're going to talk us about chemistry and warfare.
Oh, thank you a lot, Ricardo. Now we're going to the area of the chemical warfare. When we talk about chemical weapons, most of them are used in form of gases. During the research of the medical agents during the First World War, it's when medical warfare took stage, when Germans places their gases in cells to apply them in fields of battle, to get higher chances to win. This turned to be very effective, but gases were not always lethal, and that would change in the 1930s, when scientists created the first nerve agent, the gas taboon. These gases have several ways to affect people. If they are inhaled, they can be almost instant reaction, but if they are in touch with your body, they can take from 5 to 10 minutes to react. The principal elements in every acid and gas are hydrogen and nitrogen. In the modern world, all these investigations have become very important for the warfare industry. But why is it necessary for us to use them? Well, gases are almost the worst way to torture someone, and even during battles are the most feared by soldiers. They last long and make effects in human population that shouldn't be admitted. In the following chart, we will show you 4 of the different principal gases used during the chemical death industry stage, in its symptoms, its persistence, and its lethal dose. Thank you a lot for your attention, and this was Chemical Warfare. We're going with you, Ricardo.
Now we're going with you, Paulo. You're going to talk us about global warming.
Well, talking about the relations with the chemistry or the science with the global warming is the climate change impact. The Earth climate is the product of complex, highly dynamic, and often non-linear interactions among physical, chemical, and biological processes occurring at many scales in the atmosphere. At terrestrial freshwater and marine surface and in depth of the ocean and landforms, while recent research advances in Earth system, science have been greatly strengthened our understanding of broad and current climate properties and processes. Our ability to quantitatively predict how the future climate will respond to continued and increasing greenhouse effect and fine particle emission is still limited. Even more limited is our ability to precisely predict how the Earth ecological and human system will respond to changes in climate. Well, now talking about in how will affect that the polar caps are melting to the Mexico climate. There are many theories about that the many states of the country will disappear. Well, how can we stop this? There are three possible solutions that I investigate that is the most common that change or decrease the use of the car. We can change it to use bicycles and other stuff of transport. The second one is to stop using so much energy. We can use the natural resources such as eolic energy or use solar panels. The third solution is that the scientists create new stuff or something that helps us to delete the greenhouse gases.
After learning about chemistry contributions to our human progress, we could say that chemistry has improved our world in many different ways. We could also say that chemistry is not an independent science. Many sciences depend on chemistry, but also chemistry depends on many other sciences. That's all for today. Thanks for seeing us.